a line is given to us, x minus 1 by 2 equals y plus 1 by minus 1 equals z minus 0 by 1. One of the point is given on this line. Let's say the point P is on the line, and from this point P a perpendicular is drawn to the plane. From this point P a perpendicular is drawn from the point to the plane x plus y plus z equals 3, such that the foot of perpendicular Q also lies on the plane, right? So one of the plane is also given to us, which is x minus y plus z equals 3. The meaning is a point P is on the line. From that point, let's say a point P is on the line. This is the line on which the point P is there. From that point, a perpendicular we have to plot on the plane, and this perpendicular is Q. Let's say this plane is known as pi 1 and this plane is known as pi 2. So this plane is pi 1 on which a perpendicular is drawn, and that Q point is also on the plane pi 2. That means Q is the intersection of pi 1 and pi 2. So let's say somewhere over here there is some plane which is pi 2. So intersection of pi 1 and pi 2 is Q, right? So we have to find out this coordinates of Q, right? Bit of complicated, but let me tell you once again. There is a line given to us. Point P is on this line. This is the line on which the point is P. From P we have to make a perpendicular on the plane pi 1. That perpendicular is Q, and this Q is also on the plane pi 2. So we have to find out the point of intersection, right? That is PQ we want to find out. Okay. So first of all, let us take a point P on the line. So P has coordinates 2k plus 1, then minus k minus 1 and k. This will be the point P, right? And now if I want to find out that let Q is ABC, so foot of the perpendicular of the plane can be obtained by using the equation A minus 2k plus 1 by 1 equals B minus k minus 1 by 1 and C minus k by 1 equals, I need to put this point in the plane, so minus, it's a foot perpendicular, so it will be 2k plus 1 minus k minus 1 plus k minus 3 by a square plus b square plus c square. So a minus 2k plus 1 equals b minus k minus 1 equals c minus k equals minus k plus k cancel, so it will be minus 2k minus 1 by 3, right? So let me compare individual terms with a, b and c, right? So what I'll get? I get a equals 2k plus 1 minus 2k minus 3 by 3, b equals, if I take on the opposite side, minus k minus 1 minus 2k minus 3 by 3, and c equals k minus 2k minus 3 by 3. So if you solve this, so we get a equals, it's 6k minus 2k, that is 4k, and 3 minus plus 3, that is 6. b equals minus 3k minus 2k, that is minus 5k, and minus 3 minus plus 3, that is 0, and c has 3k minus 2k, that is k, oh sorry, it's by 3 here by 3, so 3k minus 2k, which is k, plus 3 by 3. So this will be the coordinates of point Q ABC. Now Q is the intersection of these two planes, right? So what will be the intersection of these two? So if I take the intersection of these two planes, so let me add them. So if I add them, so we'll get xx or if we do the subtraction, so xx cancel, that means y equals 0, right? Y equals 0, that means this will be the y coordinate of point Q. So this will be 0. So it means phi by k equals 0, that is k equals 0. And for k equals 0, what will be the value of A? It will be 2, B has 0 and C has 1. So coordinates of Q are 2, 0 and 1. This will be your answer. Right? Bit of complicated, but it's easy to understand this point. See, this is an equation of a foot perpendicular drawn from the point on the plane. Like x minus x1 by a equals y minus y1 by b equals z minus z1 by c equals minus ax1 plus by1 plus cz1 plus d by a plus b plus c. Right? In that case, ABC is representing the normal. Here I took ABC as the coordinates of A. That's why. Right? So let's talk about the next question. Okay. So in next question, we have given one determinant. We have given a determinant x 2 minus 3 minus 6 minus 3x plus 2x minus 1 x minus 3x plus 2 equals to 0, and we have to find out the sum of the roots. We have to find out sum of the roots. That we have to find out. Right? So it's not proper way to go with the direct simplification, right? Otherwise we'll get an equation in form of a cube, right? We'll get a cubic equation. So let's first try to give some basic simplification, and if we get something common, so we'll try with that. Okay, so the first equation I will do is, if you just check, if I multiply this row with minus 1 and if I add in the first row, so what I will get? Multiply second row with minus 1, so I will get x minus 2. Minus 6 plus 3x, so 3 common, again x minus 2, and x minus 1 minus x plus 3, that is again x minus 2. So I can take x minus 2 common maybe, right? So let's go with the first operation, which is r1 to r1 minus r2. Okay, so it is x minus 2 minus 6 plus 3x and minus 1 minus x plus 3, that is 2 minus x. Remaining terms are as it is. So I can take x minus 2 common from the first row. So here it will be 1. Take 3 common. So at my x minus 2, that is 3, and here minus 1. Right? So 2 minus 3 minus 3x 2x, x minus 3 and x plus 2 equals to 0. Right? Then try to get 0, and to get 0 let us go with the first column. Right? So multiply first column with minus 3 and add into the second column. So C2 tends to C2 minus 3C1 and C3 tends to C3 plus C1. So by using these two operations, what I'll get? 1 to minus 3 as it is. Here it will be 0. Okay, I multiplied this first column with minus 3, so it will be minus, I can say 6. Right? So it's minus 3x minus 6. Again it will be minus 9. So plus 9, so it will be 2x plus 9. Then here 0. Okay, I directly add, so it will be x minus 1, and here it will be x minus 1 equals 0. So can we take something common? Yeah, so we can take x minus 1 common from the third column. So now it will be x minus 2 and x minus 1 with 1, 2 minus 3, 0 minus 3x minus 6, 2x plus 9 and 0, 1, 1 equals to 0. And now let us give the expansion from the first row. So we'll get x minus 2, x minus 1, minus 3x minus 6, minus 2x minus 9 equals 0. So x minus 2, x minus 1, it it's minus 5x minus 15 equals to 0. So x minus 2, x minus 1, and it's minus 5 I'll take common, so x plus 3 equals 0. So how many roots are there? The roots are x equals 2, x equals 1, and x equals minus 3. So if I want to find out sum of roots, so sum of roots 1 plus 2 minus 3, which is equals to 0. Question, we have given A, B, C are in GP with a common ratio 0 less r less or equals to 1 by 2. 3A, 7B and 15C are in AP, which is given. So we want to find out the fourth term of AP. T4 we want to find out. Okay. So let me take here as the first term as A. So B can be written as AR and C can be written as AR square. Right? Now if 3A, 7B and 15C are in AP, so according to the rule, is 2 times 7b equals 3a plus 5c. Now let's put the values in terms of a. So 14 into b. B has answered AR equals 3a plus it's 15 and 15 into AR square. So we can cancel a from both the side. So 14r equals 3 plus 15r square. So 15r square minus 14r plus 3 equals 0. So the roots are, if we want to make a factors of 45 whose addition is 14, so it will be 9 into 9 and 5, right? So basic rule of factorization, minus 9r minus 5r plus 3 equals 0. So first factor will be 3r minus 1 and second factor will be 5r minus 3 equals 0, right? So r equals either 1 by 3 or r equals 3 by 5, right? Now r equals 3 by 5 is not possible. This is not possible because it does not belongs to 0 to 1 by 2. So r has 1 by 3 is the only answer, right? And if r has 1 by 3 answer, so 3a will become 3a. Will be 3a as it is, right? Because a is the first term we could consider. Okay, 7b as what? 7b as a into r and r is 1 by 3. So 7b as 7 into ar, a into r, r as 1 by 3. So 7b will be 7a by 3. So what will be the difference? These three are the first three terms given us. Sorry. First three terms, right? So common difference will be what? 7b minus 3a. So 7a by 3 minus 3a. So it will be minus 2a by 3, right? So if I want to find out T4, which is a plus 3d, so a is the first term, which is 3a plus 3 into minus 2a by 3. So 3a minus 2a. So T4 will be a. Right, this will be your fourth term. Clear? Next point. The sum of the terms we want to find out in this 24. The sum 1 plus 1 cube plus 2 cube by 1 plus 2, 1 cube, 2 cube, 3 cube by 1 plus 2 plus 3 up to 15 terms we want to find out. And minus 1 by 2, 1 plus 2 plus 3 dot up to 15. This is we want to find out. So this first 1 plus 1 cube plus 2 cube dot up to 15 terms, right? So the final term will be 1 cube plus 2 cube plus 3 cube dot up to 15 cube by 1 plus 2 plus 3 dot up to 15, right? And minus 1 plus 2 plus 3 plus dot up to 15 by 2, that we want to find out. So let us first of all write down the generalized equation. So the general equation will be summation r equals 1 to 15. I can say it's 1 by 1. So this can be r square, r plus 1 whole square by 4, and in the denominator will be r plus 1 by 2, so into 2. Minus 1 by 2, it's 1 plus 2 plus 3 dot up to 15, or I can say, I can also replace this as 1 by 2 summation r equals 1 to 15 with r, right? So 2 by 4, which is 1 by 2, summation r equals 1 to 15, r plus 1 can be cancelled, so r into r, which is r square plus r, minus half r equals 1 to 15 r. So if you just check, half r equals 1 to 15 r square plus half r equals 1 to 15 r, and minus half r equals 1 to 15 r. So these two terms will be cancelled, and in r square it's 15, 15 plus 1 16, 15 2s are 30 plus 1 31 by 6, and when you solve this sum, this term will get answer as 620. This is your answer. Right? Quite easy. Next question. The next question, we have given one integration. It's x raised to 5 e raised to minus x square dx equals to g of x e raised to minus x square plus c. Then we have to find out g of minus 1. Okay, so first of all, let us get the answer of this integration. So I equals, I can write down like this as x square whole square e raised to minus x square into x dx. Just check. X square, that is x square whole square, that is x raised to 4 into x raised to 1, which is x raised to 5. And now let us take the substitution, that let x square as t, so 2x dx equals dt, and x dx equals dt by 2. Now if I put these values, so 1 by 2 outside, x square we took as t, so t square e raised to minus t dt. So now let's go with the integration by parts, where t square as u and e raised to minus t as v, right? So let me clear this. U equals t square and v equals e raised to minus t. So according to the integration by parts, u as it is, e raised to minus t as integration e raised to minus t upon minus 1 minus half integration t square as derivative twice t into e raised to minus t upon minus 1 dt. So minus half t square e raised to minus t, minus minus plus 2 cancel, it's t e raised to minus t dt. Now in this term again we have to apply integration by parts. So the first term, minus half t square e raised to minus t as it is, and this again t as it is, e raised to minus t as integration e raised to minus t upon minus 1 minus integration t has derivative 1 e raised to minus t upon minus 1 dt. So minus half t square e raised to minus t minus t e raised to minus t minus minus plus, and e raised to minus t as integration again e raised to minus t by minus 1, so it's minus e raised to minus t plus c. So now from all, if I take e raised to minus t common, so I'll get minus half t square minus t and minus 1 plus c, right? And now let's put the values. So it's e raised to minus x square minus x square by 2 minus, sorry, it's x raised to 4 because we took t as x square. So minus x raised to 4 by 2 minus x square and minus 1 plus c. And now if you compare this with this condition, so gx will be what? Minus x raised to 4 by 2 minus x square minus 1. And now if I want to find out g of minus 1, which is minus 1 by 2 minus 1 minus 1, and your answer will be g of minus 1 as minus 5 by 2. This is your answer. Okay.